So when I realized that was in the imagination section, I thought, oh, I never thought that law would be imaginative. But actually, what I'm trying to do with robotics is to some extent creative, despite being really down to earth and analytical. So I hope not to bother you too much with this talking about, but I try to keep it interesting as much as possible. So what I want to talk to you today about is what RoboLaw is. RoboLaw was a FP7 research project financed by the European Commission. But this term is used beyond that. It's used to refer more generally, more broadly, to the interaction of law and robotics. So I want to tell you what my take on the term RoboLaw is, and what are the conclusions of the RoboLaw project in this sense. And in particular, I will be talking about the problem with risk management and what is happening outside Europe, and of the future and of the present as well of RoboLaw. I'll try to keep it very simple. So what RoboLaw is not. RoboLaw is not a cousin of laws of robotics. It has nothing to do with that. Instead, RoboLaw was a quite detailed analysis of the legal and ethical implication of emerging robotic technologies in Europe. And it was, as I said, a project financed by the European Commission that came up with a series of guidelines addressing some kind of technologies and proposing some solutions, some ideas that the European Commission and the European Parliament could use to come up with new regulation where necessary or to adapt existing ones so that we can better handle these new emerging technologies and fully exploit their potential and their beneficial implications, and maybe also make Europe of a relevant area in the market for robotics, not just on the purchase side, but also on the supply side of the economy. And what were the fundamental ideas that I and a colleague of mine presented to the European Parliament? Well, first of all, robot is an a-technical term, meaning that there is no a specific technological definition of robots, and engineers most of the time disagree. You probably know this better than I do about what should be understood with the term robot. And this also entails, from a legal perspective, that we cannot develop the code of robotics, namely the laws that apply to all sorts of robotic devices without any distinction. And therefore, this suggests that we should adopt a bottom-up and functional approach in the regulation of robotics, meaning that we need to take into account specific classes of applications and the specific legal and ethical issues those classes of application raise, and address those specifically without the aim of creating a broad umbrella to encompass all robotic application unitarily. And what robot are is very different. I have put up some pictures to show different kinds of robotic technologies. We have the robotic hand, we have Watson, that is a software deprived of any physical body. We have the Da Vinci surgical robot that is completely controlled by a human being, so there is no real automation in this case. Then we have a driverless car, and the last one is a nice robot that was developed in Pisa to collect garbage. And that operates completely autonomously. Comes to your house, picks up the garbage, and brings it to the dump. So if robots are so diverse, we need to rather focus on the peculiarities that differentiate each class of robot from the other. And therefore we need to adopt this, what I call a functional approach to regulation. So the profound technical differences lead to this case-by-case approach, but also similar technological traits may raise different issues and give rise to different societal concerns. So the capability of a driverless car to operate autonomously does not give rise to the same kind of concern of an assistive robot that is intended to live with you at home, or maybe take care of the elderly or people with disability. Moreover, the same legal issue, for instance, the legal issue that is common to most robotic devices is that of liability rules. And I'll dive into more details in a moment. But we need to rethink probably our liability rules at the European level. But we cannot find the same solution or apply the same solution to all sorts of robotic applications, because different kinds of applications require different technical solutions in a legal perspective to address the problem of liability. That is one of the most relevant ones. Liability, for those that have no experience with the law, is the sets of rules that tells who has to pay damages when something goes wrong with the use of a robot. So what we did was to address 4 case studies that we selected because of their novelty, their potential impact on the market and on our society, as well as their imminence. And these devices, these applications that we considered were driverless cars, surgical robots, robotic prostheses and exoskeletons, and robot companions. Robot companions are those precisely that are intended to live with you at home and maybe take care of people, the elderly and people with disabilities in the first place, but also stay with us and help us with our daily chores. Why did we choose these? For the reasons mentioned above. Could we have chosen other applications? Of course we could have. What is most relevant is that we developed a methodology, at least that's what I think, that can be applied to many other kinds of or classes of applications of robotic devices. And therefore, the time constraints force us to pick for kind of technologies, but we are continuing with our work in addressing new kinds of technologies, and I will get back to that in a moment. So what was the robot law methodology? First of all, having a case-by-case approach that allowed us to start with a technological analysis of all the applications that we studied. So we wanted really to work in close contact with engineers to truly understand what these devices can do and what they cannot do, so distinguish reality from science fiction, the way they operate and the environment where they operate, the way they function, so that we could better understand what the real concerns, what the real problems that could be that robots bring about. And then we also did some ethical analysis. We had philosophers in our team that help us understand all the social concerns of robotics. And finally, we underwent a legal analysis. What are the most relevant conclusions that we could sum up in very briefly of the Robot Law project? Well, the first conclusion is that most likely current applicable liability rules do not work well enough. Most likely they do not provide correct incentives. What do I mean by that? Normally product liability rules and product liability rules in particular try to achieve 2 outcomes. Make sure that the products are safe, because if you force the producer to repay all the damages that these devices causes, he will have an incentive to make safe products. And also to ease the position of the victim, so the harmed party, and make sure that they can obtain some sort of compensation. But there are grounds, I won't dive into those grounds unless I receive questions on that, to doubt that this is the case. This is a problem that is not just limited to Europe. It's probably having in common with the United States most likely, but our product liability rules are not working as they should, and we're not achieving those outcomes. So what I suggest to solve this impasse is to move from an approach where the aim is to blame someone, to blame the producer for doing something bad, to manage a risk, to an approach that emphasizes the minimization of the risk for the user and for the bystanders. These should also favor the development of a market for robotics. They should allow producers to get their products to the market, which is the major concern today, because we have a lot of relevant research in our labs that doesn't get to the market soon enough. And we also identified the need for narrow, tailored technical standards. The engineers in the room will understand this better than I do, but as of today, we have, for instance, no technological standard to test a learning robot, a robot provided with learning capacity. So if you take the iCup that they have developed in Genoa, in Italy, it can learn to detect images and figures. And yet, the only thing it can be tested against is the strength of its arm. Because the only technical standard that it's used to certify its safety refers to the strength of the arm and not to the learning capability of the robot. This, of course, is a problem, is a major problem. And this, again, is a problem that is not common just to Europe, but also to the United States. We also suggested the development of a European robotic agency to address this kind of concerns. And this is intended to be an independent body that helps developing and updating technological standards and making suggestions about how the law should be adapted when this kind of application starts emerging in real life. And then we put an emphasis on real-life testing, and I'll get back to this in a moment. So what I mentioned before, the issue of risk management. The idea of risk management is that in order for innovation to reach the market and to become a product, you have to develop a strategy, a risk management strategist that allows the producer to calculate the risk that he is facing by putting that product onto the market, and that allows the victim to obtain a prompt compensation in case something goes wrong, because no matter how safe any device is, there will always be someone that gets injured using it. So what is the problem with risk management in robotics? The problem is that it's twofold. First of all, we have a problem in identifying the risks that we are exposed to, because these applications are so novel that we do not know exactly what kind of risk will materialize. And even less we know how we can handle those risks and how we can assess them, meaning how frequent there will be and those accidents and what kind of impact they will have, how serious the damage that they cause will be. So to identify the risk, we have to distinguish material risk from legal risks. Material risks depend on various things. So for instance, if you take a robotic hand is intended to, once it is implanted onto the human body, to follow the human being in all his day-to-day activities. That could range from shopping for groceries to training in a gym and driving a car. The same malfunctioning occurring in these three different scenarios would cause very different accidents and would cause very different damages. And the producer would respond of all of those. So it's very difficult if you think of a humanoid robot that could follow human beings as, again, in his daily interactions, that again would be a really relevant risk. And it's very hard to materially identify those risks. And the legal risks derive from the fact that liability rules are not so clear because they weren't developed thinking of robots. And so alternative liability schemes may overlap, in particular product liability rules and all other sorts of torts that are existing in all legal systems in Europe and beyond. So how to address the issue of the identification of material risks? Well, one good example of something that is being done quite well is the ECHR++ program. Probably many of you here will be familiar with it because also the University of Bristol is involved in it. And but this is like the development of testing areas across Europe where not really real life testing, but as close as possible to real life testing is allowed for researchers and developers of robotic applications. We need more of this. We need more of this, and in a moment I'll show you that other countries are doing much more than Europe is doing in this direction. And we need to fill this gap as soon as possible. We need empirical testing, we need real-life testing of robotic devices in order to be able to identify the material risks that these devices may cause. And then, in order to address legal risks, at times we really need to develop some precise definitions. For instance, as of today, there is no definition of driverless vehicle in Europe that allows the circulation of those devices on European streets, even for experimental purposes on a general level. And then we need to start thinking of alternative liability schemes. I am doing some empirical analysis, taking comparative and empirical analysis of alternative legal liability schemes that could substitute private liability, including no-fault plans, but not just that. Compulsory insurance schemes and other strategies. And legal risks also depend on the fact that oftentimes they depend on very elastic notions. And those notions can be interpreted and applied in very different ways. For instance, a typical example would be the notion of defective product. Many people may understand something different by that. And therefore, the application of the notion of defective product will lead to very different outcomes in different European countries. So these are the roots, these are the implication of the legal risks. How to assess these risks? That is another problem. Because we do not have relevant statistical data about what robots do. So if we had an increasingly autonomous vehicle on our roads, we would know nothing about what conditions cause it to crash. So as of today, we know that a car driven by a human being crashes because the human being is either distracted or testing or drunk or tired. But when the car is driving, we don't have that information anymore. And so that insurance companies have very little a clue about how to calculate the insurance premium. And so I'm in close contact with insurance companies that are extremely concerned about this. They know that this technology is coming up. And I'm not talking about the Google car that drives fully on its own. I'm talking about a car that first of all will go parking on its own, and then maybe will drive on its own under certain conditions. But this will modify the structures and the reason of the accident so profoundly that insurance companies won't be able to manage those, won't be able to offer insurance products. And if they do not manage to offer insurance products, we cannot put those devices on the streets and let them circulate. So this is basically the problem with risk assessment. Again, we lack empirical data, and we need to develop alternative strategies to acquire that data, because we cannot wait decades until we know, for whatever reason, an increasingly autonomous car crashes. We need to have that information soon. And that is related to the data flow and the Internet of Things, and I could dive into details more about that, but we don't have time today. So, what are the solving strategies for these kind of problems? We have to undergo technical risk assessment studies of technologies, basically what RoboLaw tried to do until now. We have to try to determine what applicable laws are, and eventually suggest modifications of those laws that promote a high level of certainty, ex-ante certainty. So I think it's way better to identify the party that is going to be held liable ex-ante, and even put the cost entirely on that party, because then this party will be able to spread it out through price mechanism more efficiently than leaving it to be determined exposed through very complicated litigation. And of course, we have to work in close contact with insurance companies to find creative ways. And this is probably the imagination part of my talk. Think creatively about how to elaborate insurance contracts to handle those risks. What's happening outside Europe? Well, Korea, since a few years now, has an Intelligent Robots Development and Distribution Promotion Act that is basically a law that states the strong determination that Korea has in developing a strong market for robotic products, and adopts all sorts of measures that they deem necessary to enable the development of those robotic devices. Japan is doing something even more extreme, I think, and very useful, and that I think is something that Europe should copy, is the development of some deregulation areas where real-life testing of robots is permitted once you obtain a specific permission by local authorities, but with a very facilitated and clear procedure that really improves the quality of liable engineers. In the United States, they have a very more limited approach, and for instance, they have adopted definitions of driverless vehicles, such as in Nevada, allowing the circulation of the Google car already for a few years now. But this is not, I think, the best model. I think the Japan approach is way preferable than any other. What is the present of RoboLaw? What is RoboLaw doing since 2014 when the project ended and we presented our result to the European Commission? Well, we started diving into many other directions of the regulation of robotics. For instance, we are recently studying the regulation of civilian drones that was recently passed in Italy, and we will do comparative studies with all other regulations that were passed in other European countries. Because drones are, of course, a kind of technology that is already out there and very relevant, and we had left it out in our analysis, but we're now addressing it directly. And we're also studying driverless cars and alternative risk management strategies. I'm working in close contact with insurance companies, and next Monday I have organized a conference in Lucca where economists, engineers, insurance companies will all meet and gather together to discuss alternative and innovative approach to the insurance problem of driverless vehicles. We have experts of cybersecurity that will help us identify the new cyber risks that this kind of devices will bring about. We have engineers explaining us the benchmarking issues, and we have, of course, lawyers and economists applying law and economics methods, modeling, and working on a game theoretical model with an economist to address this very specific issue. The future of RoboLaw, which is already to some extent present of RoboLaw, is this other project called Reliable. It's a project that I am coordinating on the legal and ethical issues associated with robotic hands and prostheses and exoskeletons that was financed by the Italian Ministry of Education. And for this project, I will be undergoing an empirical law and economics study of all product liability rules across the world, not just Europe, but also including China. And the aim of this research project is to identify the weak points of product liability and come up with a very concrete, narrow, tailored proposal for the European Union to replace it in all cases where it does not work. And at the same time, the future of RoboLaw is also this other project that I'm also coordinating, which is called Europe Regulates Robotics. It's a summer school that will last, that will be offered over a 3-year period just to start. It's a course on the law and economics of risk management and a course on robotics and machine ethics that will be offered in Italy, with the attempt of training the European lawyers and engineers of tomorrow. This is a project co-funded by the Erasmus Program Plus, the Germany Action, and the Scuola Sant'Anna, of course, where I work. And it's really aimed at creating lawyers that are capable of understanding the technical aspects and the technical issues robotic devices bring about, and also create engineers that are capable of doing the same. Because Europe is moving into one good direction, which is the called X by design. So privacy by design, for instance, safety by design. What does that mean? That engineers will have, in the moment they program their robots, in the moment they conceive their new applications, they'll have to have a very good understanding of what the law says and choose one solution over the other, also for its ability to minimize the legal risk or to avoid the legal risk. And therefore we need new lawyers and we need new engineers that are capable of working tightly together with one another. And the idea of the summer school moves precisely in this direction. It will be offered starting summer 2016 to law graduates and also engineering graduates. It will dive into the details of the existing and applicable regulations and all problems of like standardization and benchmarking that are great values for engineers. Thank you.
I was just wondering, I love the work you're doing, sounds absolutely right and fantastic. I was just wondering if there would be any resistance to laws we find that you kind of banging your head against the wall because people have some silly ideas, like I was talking about my talk about, well, why do I surely have to regulate robots to stop them from killing us? That's just not what robots do. Do you ever meet that kind of attitude? Is that a problem for you?
Yeah, well, there are some people that have some kind of really unrealistic ideas about, I once had to spend 1.5 hours with a British journalist trying to explain that I in no way intend to make the robot liable. And it makes no sense to me to hold the robot liable, or to give rights to robots. This is again, that kind of stuff that gets to the headlines of the newspapers, and that we have to fight against. So when I said we have to keep very neatly separate what is science fiction from what is a very serious technical analysis. Before getting into robots, I was studying capital markets contracts and the regulation of capital markets. So I'm trying to apply the same kind of serious analysis that everyone would put into discussing financial contracts, into discussing a topic that is at least as serious and at least as economically relevant, that is that of robotics.
From a European perspective, is it problematic that the legal systems of the member states can be so different?
Not really, because the kind of regulation I'm thinking about and the kind of issues that we need to address are those that are already today regulated at the European level. So the Defective Product Directive applies to all European states. Of course, there's some differences in the way it's applied, but that is always the case. And that is always the case also within the same national state. So that is not a big concern. And I think that the best level where to act is precisely the European level, because we cannot have a piecemeal regulation where each country goes its own way. So there are some cases where we are already going our own way, which is precisely drones, because those are easier to regulate and there are a strong economic interest in using them. But we need to come up with reasonable solutions also about that. But with respect to all the rest, we really need to act in a timely fashion, but not in a rushed fashion, because we need to do some very attentive assessments of how effective existing regulations are and what are their weaknesses. Because otherwise we'll simply come up with a new idea that is not sufficiently grounded on empirical data, and the solution that we propose will be as ineffective as those that we already have today.
Since we won't have you this afternoon, I wanted to ask you what you would tell startups who have a project that they'd love to put out there, but they don't have a legal framework to do that.
Well, that is one of the major concerns. I know a lot of people that have startups that don't manage to get to the market, and that's why I'm so passionate about this research. They may not avoid the problem. They need to find a lawyer that can handle this kind of analysis, and they need to get an attentive study, and they need to work in close contact with their insurance companies if they have, because otherwise they will soon find themselves in a very bad position. And this is also the reason why I'm hoping to train some new kinds of lawyers.
Okay, excellent. Oh, one last question.
Could you tell us more about these deregulation areas? How can I imagine how big must they be, and what are the conditions? To whom does it apply?
Okay, so these deregulation areas are as big as provinces, like basically are entire provinces in Japan. And in those areas, like the testing in real life scenarios of robots is permitted, of course, under conditions of safety. But what they do is basically they ease the otherwise impossible to solve procedure of obtaining the permission of all local governments and all local authorities, because what they want to do at times conflicts with the street code, at times conflicts with other kinds of regulation. And so if they had to ask permission one by one, in some cases they would not be able to go around laws. It's very hard to go around the laws of like the street code that are of a national level, and even the local authority has very little to say about that, but also on more relevant local restrictions. So creating those regulation areas where there is a clear procedure that can be followed well, of course, conditions of safety are granted, but to some extent also the experimentation of robots is permitted. So for instance, they would test an Android robot in a mall, in a supermarket, so in between human beings. We did something similar in Pisa with the dashboard that I showed before, but it was extremely complicated to obtain all the permission, and that was only possible because it was a small village, and the mayor was really enthusiastic about the opportunity of having a robot being tested there. And it was a very successful experiment, performed under extreme safety conditions, like where everything was double-checked and triple-checked and controlled by purchasing comprehensive insurance coverage, but yet it was permitted. It took a long time to get the authorization to do that. So if we could cut those times down and leave that time to research, that would be extremely beneficial.
Thank you.